Hi, this is our second video for the morning. This is alkenes and alkynes. An alkane is a carbon chain with single bonds. An alkene means we have double bonds, that's Ene, and an alkyne, Yne, means that we have triple bonds. Okay, so what you're going to notice is if you've got a carbon chain, it will always get straightened out by a double or a triple bond, and you'll see what I mean as we go through this. So what can happen when we're working with one thing I wanted to show you was that priority list we had, and on that priority list what we can see is that a double bond is more important than a triple bond, and a triple bond is more important than a methyl, ethyl, or propyl. So if you have a double bond and a triple bond and you want to know what end to start counting from, double bond takes priority. Okay, so when you guys studied double bonds in grade 11, you did cis-trans isomers. So what can happen is when you've got a double bond, the tails can either go up and down, or they can both go in the same direction. They could both go up. If they both go up or if they both go down, that's cis. Cis means same. When the tails go in opposite directions, that's trans. So trans is different. So if this tail went down and this one went up, that would still be a trans. So if both tails are both up or both down, that's cis, or if they're going in opposite directions, that's trans. So what we do is we find the longest chain, 1, 2. It's always a dot at the beginning and the end of the double bond. So it's 1, 2, 3, 4, 5, 6. So what we have is we've got hex. This is hexene because it's got a double bond in it. Where is the double bond? It's on the third carbon. So that is 3-hexene, and it is trans. Okay, so out front of everything, if you've got a double bond in there, you've either got to say cis or trans. Let's try and name one. Always find your longest chain. 1, 2, 3, 4, 5, 6, 7, 8. This is oct. Find your double bond. It's there, so that's ene. Lowest numbering, 1, 2, 3. It's on the third carbon. Now find your functional group. So if that's the third carbon, fourth carbon, fifth carbon, we've got a methyl. Sixth carbon, we have a methyl. So we have 2 methyls. That's dimethyl. And where are they? 5, 6. Remember, it's commas between numbers and dashes between numbers and names. Let's try and draw one. Trans 2-methyl-hexene. Hey, whenever you've got a double bond in something, always start drawing at a 45-degree angle going down. 1, 2, 3. I forgot a number in there. That should be trans 2-methyl-3-hexene. Remember, work backwards when you're drawing things. So your hexene first. When you get to the double bond, put the double bond straight across, and now start working your way down again. 1, 2, 3, 4, 5, 6. So there is a methyl on the second carbon. It is trans 2-methyl-3-hexene. Hey, once again, if you have problems on this and you're working on the worksheet, send me the problem you're having. So be explicit about what it is you want me to work on, and then I can do a drawing for you. Okay, so I can work on the ones. Don't get frustrated. If you have problems with a few of them, I always suggest go back and watch this video again. Send me the problems you're having. I'll make another video and I will take them up. I want to talk about something I missed out on in the first section that we did. So I just used a term called isomers. So iso means different and mer means molecule. This is different forms of the same molecule. You'll notice that these are exactly the same. They are both C6 H12. If you counted all the hydrogens on there, it would be 12. So isomer means different form of the same molecule. They're both C6H12, but they both have a different name. I want to show you something called structural isomers. I'm going to show this to you and then we're going to forget it, but it's got a couple of important teaching points that have to do with what we did in the last video. So what I want you to do is look at the number of carbons we've got. 1, 2, 3, 4, 5. We have 6 carbons in this full structure. In this one we have 1, 2, 3, 4, 5, 6. We've got 6 carbons there. Now what I want you to do is count all the hydrogens. Well, how do you know how many hydrogens you have? Every dot must have 3 bonds or 4 bonds coming away from it. The dots represent carbons. Carbon always has 4 dots. Well, that's not always true, but in organic chemistry it is. So that means we've got a line coming away there, so we must have 1, 2, 3 hydrogens coming off of it. So you need 4 lines coming away from each carbon. So if we look at this one here, we've got 2 lines coming away from it, so we need 2 more lines, so we've got 2 hydrogens. This dot has 1, 2, 3 lines, so it needs 1 more coming away, so it's got 1 hydrogen. So altogether you've got 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's the bottom line. If you don't have any double or triple bonds in a structure and all you have is single bonds, if you want to know the number of hydrogens, double the carbon number and add 2. So 6 plus 6 is 12, plus 2 is 14. That will tell you how many hydrogens you have. Even though this structure looks different, it will also have 14 hydrogens. I think the big take-home point for you is that every carbon needs to have 4 bonds or 4 lines coming away from it. I'm going to take a minute and I'm going to name these. 1, 2, 3, 4, 5. So it's pentane. 1, 2, 3. It's 3 methyl. This one, 1, 2, 3, 4, is a butane. 2 and 3 dimethyl, so it's dimethyl because it has 2. Notice I'm working backwards, chain length, then side chains. Where are they? They're on the 2nd and the 3rd carbons. So the di tells you you've got 2 methyls. The 2 and 3 tell you where those 2 methyls are. These are called isomers because they have the exact same formula, C6H14, but they have different names. These are called structural isomers because they do not have double bonds in them. This will be the last time we talk about these isomers in this course. I only introduced these isomers to show you there are different types of isomers, and also so we could count the hydrogens on the carbons. This is video 2 for the day.